In this video, I want to talk about making decisions and conclusions based on our rejection rules. And when we look at these things, we have to understand what a p-value is, what the level of significance is, and how we use those things to connect our decisions and our conclusions. So when we talk about our rejection rules, we're going to focus on this thing that we call the p-value again. And by definition, the p-value is the probability of getting a test statistic or something even more extreme if in fact the null hypothesis is true. And in those notes, I told you that this p-value essentially says how likely is something to occur by chance. And if we look at this first example, I want to relate this to making a decision. And to do that, the first thing we do is start off with our hypothesis again. So it says the school publicizes that the average class size of its students is 25. And remember for this, what we're going to do is we're going to underline our parameter, which is that we're talking about the average class size. And we know that our null, H naught, is mu is equal to 25. The alternative, HA, a PTO thinks that it is larger. So HA has to be mu is greater than 25. Now, here's what happens. It says at the 5% significance level, a hypothesis test is conducted, and the p-value is found to be 0.3. So essentially what this is saying is that when we conduct this test, and we go through everything, and we get our test statistic, we get a p-value that is equal to 0.03. So the p-value again is a probability. So the probability of something occurring is 3% chance of probability of having a class average size of 25 or something bigger is what this is saying. If in fact the stated mean or the stated 25 is actually true. So basically the school is stating that the average size is 25 or something. We're not going to test less. We don't think it's less. So the school is stating that the average is 25 or something less. The PTO says there's too many people in a classroom. We're seeing way bigger classrooms. We're seeing classrooms with maybe 28, 30 kids in them. And they've gathered data. And when they gathered that data, what they found is that they keep finding all of these classes that are bigger than that average mean of 25. Well, remember, there's this random sampling that's taking place when they gather some sample to sample, which means you're going to have different samples every time you take a sample. But what should be true is that if the average is 25, most of the samples should be around 25. In this case, though, what they're saying is by doing the sampling process over and over again, there's a 3% chance that every time we pull samples, we're pulling samples that are going to be bigger than 25, just by random error. Which basically tells me that, hey, something's not right. Well, I'm going to mathematically quantify that now by looking at this significance level, alpha. And alpha says this now, if we were to draw a normal curve, and because this is a right tail test, our rejection region falls out here. This is the rejection region alpha. And this is equal to 0.05. We've gotten a test statistic that gave us a 3% of getting it as that value or something even more extreme, which means we've gotten a test statistic that sits out here where this is the p-value equal to 0.03. Notice where it falls at. It falls in the rejection region. Up here, look at your rejection rules. It says if the p-value is less than alpha, we reject. If the p-value is greater than alpha, we fail to reject. Notice what we're rejecting. We're rejecting the null, or we're failing to reject the null. The decision then always focuses on the null hypothesis. And here, my p-value, 0.03, is less than my alpha value, which is 0.05, my significance level. Because of that, I will reject H naught. That's the first step. That is the decision. Now that I've rejected H naught, I need to make a conclusion. So if you think of a court case, what this is saying in a court case is that I'm rejecting your innocence, because the not in a court case is that you are innocent. I am rejecting your innocence. Now that I've rejected your innocence, what am I saying? Well, I'm saying you're guilty. Well, why am I saying you're guilty? I am saying you're guilty because there's enough evidence to support that. And so when we write the conclusion looks like this. You're going to reject H naught. You're doing that because there is enough evidence. And your evidence is that small p-value. There's enough evidence to support HA, the alternative. So 2 parts of this. There's a decision. The decision here is to reject, and you always reject the no, or you fail to reject the no. Your decision is always with respect to the no. The next part, though, comes to the conclusion. The conclusion talks about the evidence either supporting the alternative or not supporting the alternative. And here it supports the alternative, which means that it's supporting the fact that the class sizes are greater than 25. So let's look at the next one. A car dealership announces that the mean time for an oil change is 15 minutes. A consumer group thinks it's different. At the 1% significance level, the p-value is found to be 0.07. So in a two-tail test, here's how this works. This time first let's define our actual value, our actual hypothesis. And our hypothesis here we see is that the first part is finding the parameter. The parameter says that the mean time for an oil change. So we see that H naught is mu should be equal to 15 minutes, where mu is the mean time for an oil change. And we know that HA is mu. They think that it's different. So it does not equal 15 minutes. Now, here's how this works, though. When we do it, we're doing it at the 1% significance level. So at the 1% significance level, looks like this. Because it's a two-tailed test, it can either fall on the left or the right. The area altogether has to be 1%. So this is 0.005. This is 0.005. And if you add those two values up, you're going to get your 1%. Well, when we calculate this, we get a value that is 7%, which is much greater than both these values here. So that 7% is going to fall somewhere in our safe region, which means that all of these values that sit inside the safe region are basically plausible values. They can occur. They can occur by chance. So it's not unheard of. It's not unlikely for this to occur. So when we write this here, here's what we're going to say again. The first thing we're going to do is we're going to compare the p-value, which was 0.07. That is greater than the alpha value, which is 0.01. And again, your rejection rule says that if the p-value is greater than alpha, you fail to reject. And again, we're failing to reject because you're falling in this plausible region. So we will fail to reject. Well, what are we failing to reject? Remember, we're going to fail to reject the null, H naught. Why am I failing to take away somebody's innocence? Because that's what you're doing. If you're saying in a court case, remember, the null is that you're innocent. If you fail to reject the innocence, what does that really mean? If I fail to reject your innocence, that means you are still innocent. Likewise, if I fail to reject this null, what does that really mean? That this is still possibly true. The mean is still possibly 15 minutes. Well, why am I saying that? If my goal was to try to prove this alternative, and I'm not able to do that, why am I not able to prove the alternative? Well, the reason I'm not able to prove the alternative because there is not enough evidence. Or there is a lack of evidence. There is not enough evidence to support HA. And again, the decision we made it with respect to the null, the conclusion we made with respect to the alternative. And we made those based off of these rejection rules by comparing a p-value to an alpha value.